Hi, and welcome to the final presentation for the REDMANE DevOps slash Sysadmin slash demo environment team for Intake 14, summer of 2025, 2026. I'd just like to say before we start that I think this team has done a wonderful job, and Sysadmin and DevOps isn't that exciting, but it's actually really important, and it's challenging for new interns, and I think you've all done a wonderful job. So without further ado, I'll hand it over to Patrick.
Thank you so much, Roland, for the introduction. First, before we start, I want to do an acknowledgement of country. We acknowledge the Wurundjeri and Boon Wurrung people on whose unceded lands some of us live and work here in Narm or Melbourne. We respectfully acknowledge their elders, past, present, and emerging. We also acknowledge all the traditional owners of country throughout the continent of Australia. We pay our respects to their elders, past, present, and emerging. Okay, so today we will talk about our team's introduction and a bit of context, and then we will do a demo. Then we will talk a bit about how we got here, our approach, reflections, both individual and as a group, and also just some closing information. Okay, I want to introduce the team. Our team consists of 4 people. There's Janavi, Niveta, Shinyi, and myself. Janavi is from the Bachelor of Science program, but the 3 of us are from the Master's program, 2 in Data Science and 1 in Information Systems. And yeah, I'll hand it to Niveta.
Yep. So I'll start with the context. What is REDMANE? So REDMANE is basically like a file system, ecosystem. We can think of it like a library catalog system, but for a research data across organizations. It mainly has 3 components. The first is the data registry, which is the central catalog of all files. It basically works like a library's catalog which tracks books. So this registry connects multiple organizations, so everyone can discover what data exists in it. And then we have data portals, specifically CBio portal and Omero here. These are like authors' websites for books. They're like tools that let the researchers explore and also visualize data in different ways. Then we also have the mock user organizations that contribute data to the system. Next so right now we're working on key stage 1, which is getting a working public demo with synthetic data. So the future interns would be working on setting up working instances of both the data portals with synthetic volumes, establishing bidirectional connections between the registry and each of the portal, and also implementing SSO so users can seamlessly authenticate across the entire system. So once this foundation is solid, the next steps would be testing with the private data and integrating number of interoperable apps and also expanding to the international partners.
Okay, I will talk about the initial state when our team joined WeHi back in middle November. So there are several problems with the Redmane ecosystem at the time in 2 levels, on the Redmane wide level and also on DevOps specific level. So on Redmane wide level, at the time SSO was not developed yet. Actually, until now, we are not finished yet because there's a protocol mismatch. So 2 of the components, which are the data registry and CBio portal, are using OIDC protocol. Meanwhile, Omero requires LDAP protocol. So at the time, this was not documented yet, but our team has documented this and also done some research on it. Also, initially, there are 4 teams working on Redmane. So initially, coordination required some initial time investment so that we understood each other's scope, boundaries, and responsibilities better. Talking on the second level, on the DevOps specific one, the data registry initially was out of sync with the latest code base. So, for example, the latest intake before us actually already had the codes of a working data registry instance with PostgreSQL database. But when we came in, both the data registry VM and also the website that it hosts are still based on the older SQLite database version. Also, there were no valid SSL certificates, so connections made to the REDMANE ecosystem when we joined was through unsecured HTTP. There were also no version control on the VMs. So whenever someone wants to do deployments, it had to be manual, and there's no audit trails yet. And also some of the Docker architecture was still in its initial state, so they're not optimized yet. For example, there was a persistent Node.js container, although its function was to just serve static files. So by the end of this summer, we were able to bring some progress. On SSL certificates, we got it done for all the VMs in the ecosystem. And also for the management side, for example, SSL certificate renewals, we are automating it through the usage of HTTPS portal Docker container. On version control, currently the data registry VM is pulling from Git, so it's already version controlled. And we have already created the documentations for future interns or maintainers of REDMANE to be able to do this Git-based deployments. In terms of containerization, it's also done on both the data registry and data portal VMs of REDMANE. Specifically for data registry, we also have done some optimizations. For SSO, it is partially done. So Keycloak as an infrastructure is already deployed, but integration with external identity providers, for example, as I mentioned earlier, we need to integrate with OpenLDAP for SSO with Omero. That is still pending configurations and deployment. And finally, on the data portal side, it is also partially done. So CBio portal has been spun up, but the data in it has not yet been synced with the data registry. And for Omero, it is currently just a placeholder page that is hosted behind an HTTPS portal container. So it's already reverse proxy and already has this SSL certificate, but it's not yet actually functional. And next, we will be going to the demo of the current state, the latest state of REDMANE. Before we start the demo, I just want to re-emphasize on the context that Niveta shared earlier. So REDMANE is an ecosystem of 3 components. It has a data registry as the main part, which will store the metadata of underlying research data files that are stored in participating organizations' computers. So REDMANE aims to be more lightweight than other research data management solutions by only storing the metadata. So the underlying files will still be stored in organization computers. Amanda will help me demo today. We will do a live demo that shows the flow between a participating organization and the data registry. Specifically, as I mentioned before, that organizations will have research data files stored in their computers. How can those data files be processed or ingested into metadata in a format that can be uploaded to the data registry? I will hand over the screen to Amanda. Okay, thank you, Amanda. So what Amanda is showing here is a page within the data registry website to register a new data set. You can specify the title, the abstract or summary, the storage site, and the file directory within the organization's computer. And what's more important is you can specify here the file extensions of interest. So for example, here, the research raw files is using .gz files. The processed files are using .bam file extensions, and the summarized files are using .vcf. So in the future versions of data registry, after registering a data set, there should be a functionality where the user can download a config file that contains all those information that we input earlier. That functionality doesn't exist yet at the moment. So Amanda will now show a different screen. We are going to SSH into one of the organization's computers. And we will assume that in this instance, in this demo, the config file is already in this computer. We are using a handcrafted one, but in the future, the downloading will be done through the data registry. So Amanda will now run a Python script. It's called update_local_v1. This is the script that will ingest whatever research data files of interest in this computer and then output 2 files. The first one is an output.json file that can be uploaded to the data registry later on. The second one is an output.html that can be run on your computer and then rendered on your browser to see whether the updates match what you actually want. And just as an additional information, the research data files in this current organization computer we got it from Genome in a Bottle, but it is downscaled, but it is still real data. And as Amanda is highlighting here, there are 4 raw data files, there are 2 processed data files, and there are 2 summarized data files as well. So we have a total of 8 data files. Now that their metadata is ingested, Amanda is showing the rendered HTML output from that Python script earlier. So it shows that 4 raw files, 2 processed files, and 2 summarized files will be updated to the data registry. Since what is displayed is suitable with what we want, the next step is Amanda will upload the JSON file to the data registry. And this can be done so by going to the project's dataset and then clicking Update Data Registry. There will be a dialog box where we can upload the JSON file. Okay, and there's a summary here of what files are uploaded and how much. Okay, now Amanda is showing the files in this dataset, so we can see that the 8 files that we wanted to be tracked by the data registry is now already registered. It is already tracked. And if we go to the raw, processed, or summarized tabs, it is showing accordingly with the number of files and the correct file extensions as well. Next, Amanda will go back to the list of projects and show you the project's summary page. As we can see, all 8 files are now registered in the data registry. That means they are already tracked. It also shows the number of total patients, samples, and the file sizes. Thank you. And I will continue to the presentation slide. Next, we will show a short demo on Keycloak.
Hello everyone. Next, I will demonstrate the role of Keycloak in our First, Keycloak acts as a central identity provider in our architecture. Its main purpose is to enable single sign-on, meaning users authenticate once and can access multiple services, including the data registry, Sysadmin, and Omero, without logging in repeatedly. Now, I'll show the login page. We can access Keycloak through this URL. Also, the connection is secure. Like all the other services in the system, the SSL certificate has been successfully obtained. So at this stage, secure access to the authentication service is working correctly. I'll log in using the Bootstrap admin account. This is the temporary administrator account created during the initial setup. We can see the warning about this. It also suggests that this account should later be replaced with permanent admin users for security reasons. After logging into this admin console, we can create real user accounts and use those user accounts. We can configure roles, identity providers, and user federation. We can also set up clients such as Sysadmin. This is where we define how Keycloak connects to external services and manages authentication flows. Now let's see what is happening behind the scenes. Keycloak is running on the Keycloak VM. If we SSH into that VM, we can check what containers are running on this VM. Okay, so there are two containers. One is HTTPS portal, which serves as a reverse proxy, and the other one is keycloak service container. So the reverse proxy ensures secure external access, while the keycloak container handles authentication login internally. So the next step for keycloak include replacing the Bootstrap admin account with permanent administrator users, completing integration with external identity providers, and connecting client applications. So we can move further toward the single sign-on.
Yeah. Thank you for the recorded demo, and Shinyi will continue.
Okay, let's quickly go through the before and after changes on each VM. First, in the data registry VM, originally there was no SSL configured. The front end was somewhat over-containerized, and the backend and database were combined within a single container, which was not ideal for separation of concerns. Now we have introduced HTTPS portal to handle SSL certificate management and HTTPS termination. In addition, the backend and database have been cleanly separated into different containers. Next, in the data portal VM, here we also implemented HTTPS portal to manage SSL certificates and act as a reverse proxy. Importantly, the reverse proxy is configured to support multiple domain names. This means the VM can host multiple portals, making the setup flexible and scalable in the future. For Omero, a placeholder has been set up behind HTTPS portal. This prepares the environment for future integration. Next. On the Keycloak VM, we also obtained an SL certificate and configured reverse proxying. So overall, the key improvement is to align the architecture across all VMs with a consistent HTTPS and reverse proxy setup. Okay.
Yeah. Thanks, Shindy. I will continue on how we got here or our approach. So basically, we approached the whole project by learning in stages. So in the beginning, we collected the building blocks first. For example, we need to know SSH. That's the most basic stuff that we needed to learn to just connect to the VMs first within the REDMANE ecosystem. And then we learned about concepts that we need to do our sysadmin work, such as reverse proxying, and then the tool to use it to do that, such as Nginx, and then the basics of SSL or HTTPS connections, and also Docker and containerization. After collecting the building blocks, we started practicing what we learned by first principles first. So initially, we just set up like simple Nginx container that just does one job. For example, reverse proxying. Some of us also helped with installing certbot in one of the VMs just to see how things work. And then we validate that whether the SSL termination has been working or not, combining the certbot knowledge with the Nginx knowledge. And then finally, then we do the refinements such as using HTTPS portal to combine the Nginx and certbot functionalities, and also taking the Docker architecture to the next stage by optimizing it. Finally, after we understood enough of the basics, we divided our work to increase efficiency. So Shinyi and Janovi divided the work on single sign-on. Shinyi did more research on Keycloak and also HTTPS portal implementation on the Keycloak VM. Meanwhile, Janovi learned more about Omero, the different security protocols that Omero uses, especially on LDAP and OpenLDAP. Niveta then helped with HTTPS portal implementation on the data portal VMs, and I helped mostly on the data registry VM with some architecture refactor, latest code deployments, and Git version control. And we're going to go to the reflections now.
All right, so during the internship, I validated the core workflow and functionality of Nginx and Serpat. I also implemented HTTPS portal on the Keycloak VM. And the last, I studied Keycloak architecture and organized configuration steps and components to guide future implementation. And regarding what I've learned, I gained hands-on experience deploying a reverse proxy with SSL. I also understood Keycloak's role in centralized authentication and the end-to-end authentication flow.
Hello, I'm Janvi. Apologies, I had a bit of a technical issue, so I joined a bit late. Yep, so what I did for this intake was, as Patrick mentioned, mostly worked on the Amero data portal. So learning about more of Amero service stack and how the data flow is with the server, web, and database components. So I worked on creating sort of a proof of concept of, by setting up the server stack on my Lima VM, and yep, just compared the Apache DS and OpenLDAP containers, and set up an OpenLDAP container to just create a test organizational unit and test users to just verify the manual login functionality. Through this intake, I think what I learned was just more about setting up Docker Compose networks, and containerization, just networking volumes, just setting up persistent volume setters and deployment, but also reverse proxy, especially with HTTPS portal, and how it works within a multi-service stack. I think another plus was just having a really strong foundation of just how authentication works. And how identity management tools, just like Auth0 and they work as well, and just how I can integrate Keycloak to work with protocols such as OIDC, but also support applications that depend on legacy protocols such as SAML or LDAP. And yeah, just seeing how, even designing how the architecture for how such a service could work, I think that was something that was really beneficial.
So during my internship, I worked mainly on three important things for REDMANE. So firstly, I wrote clear guides and instructions which helped my team to deploy the system correctly and also to refer easily. And then I secured the Omero landing page with proper SSL certificates through an Nginx reverse proxy. This means the users can access the portal securely over HTTPS. Then I solved an important challenge, which was making the data registry SSL certificates persistent across the Nginx container during restarts. Without this, we would lose certificates every time the container restarted, and now they're stable. Beyond this, I also learned how to set up secure web servers using containers and automatic certificates. But equally important, I discovered that keeping a solid technical diary, documenting what we did and why simultaneously while working, was very important and helpful for teams to repeat the deployments and also share their knowledge.
Yeah, and what I did was I upgraded the data registry setup. Previously, our team used Nginx and Certbot first, but I upgraded it to the HTTPS portal implementation. Next, I migrated the data registry database from the older SQLite version to the most recent intakes code base of using PostgreSQL. And then finally, I deployed this latest version of data registry using Git and also using Docker. What I've learned is first the individual architectural needs, for example, reverse proxying, SSL management, and so on, and then see how they connect and then combine them into better solutions such as HTTPS portal. And I also gained my first hands-on experience in deploying codes and also version controlling through Docker and Git. And we'll move to our reflections as a group.
So, as a team, we learned three major things. First was understanding the bigger picture before jumping into the technical details. Instead of just fixing problems, we learned why the whole system matters. And secondly, working together remotely was pretty challenging. So, as communication and task planning are really important, we learned to be clear about who does what work and when. Then thirdly, good documentation saves time. So keeping a technical diary meant that the team could share their knowledge and also repeat and check on what we worked on. So what we would have done with more time was we would have finished integrating AAF, which is like the login system that lets the users to sign in once and use everything. We would also set up the full Omero system and connected the databases better between different parts. But what we built right now will help the future interns continue this work next.
And next part of the group reflection is what went well. We gain practical DevOps or sysadmin experience. As Roland mentioned, it is usually a work in the background, but it's actually very important to get systems running. And we realized that it's a rare opportunity to be able to work on this side of IT projects. And also, Roland's availability really helped. Roland set up daily stand-ups up to twice a day on most days. And Roland is very responsive for emails. So whenever we ask questions, Roland will give the response to us promptly. In what we think can be improved is as the program is nearing intake 15, all the progress are getting more complex. So we think a living document or a single source of truth document that captures REDMANE's goals, architectural decisions, and also latest current states. It probably needs to be established so that we can streamline onboarding process for the future interns and hopefully reduce repeated rediscoveries. And we're on to the closing part.
All right, so here are the QR codes for key links, including technical diaries and GitHub repos. Next. We'd like to thank WeHi for the internship opportunity, Roland for the guidance and teaching, and past interns for their contributions. And that's all for our presentation today. Thanks for listening.
Really well done. Really well done. And I just want to reiterate what I said at the start. DevOps and sysadmin is a challenge, just generally, and it's even more of a challenge for interns because I don't get to do it very often. Usually, a lot of the products that are available are there so that you don't have to do it. So for this group to work together on a complex project, doing DevOps remotely, and doing so well and collaborating so well is extremely impressive. So really well done. I'm not just saying that